Okay, so we're recording now and we should be good to go. I'm assuming you guys can see my board and we won't have the problems that we had in the other class. I hope you can hear me loud and clear. Great. So before we start, those of you who are here, do you have any questions for me? Okay, here I got somebody else there as well. These other people keep joining. Okay, so what we'll go through today, assuming that you haven't really grasped what I was talking about, so let me switch over the camera. PW231. I'm hoping that you guys do spend some time. We'll briefly check on the week one content. Today is week two, so we are recording. I want to also mention that the theory portion will be covered by me. That's me, Sajad. And we have about 2 hours per week. And then the lab portion will be Professor Javan. I believe that's about 2 hours per week, but that will be in person. So just to reiterate, this is online, asynchronous. What does that mean, asynchronous? So what that means is I record it and post it. So I'll make a recording here in Zoom because as we all saw, it was just not a good experience in the other platform earlier, right? Do you guys agree that this is a better platform? I know Ilya, I think Stephanie, you were there as well this afternoon. So now, yes, I'm recording it, but I would post it. But I am giving you the option, and I love it if you attend the live recording. Why? Because I like to interact with you guys, and you guys are able to give me some feedback, or if you have any issues or concerns, you guys can talk to me right here. Okay, so before we start, let me open up the floor to any questions that you guys might have. Give it a few minutes. Any questions? Because yes, we didn't meet last week. But the week one, the week one information is posted in the content section. So week one info is posted. It's posted. And you might have to catch up if you haven't gone through it. Okay, let's see. I'm seeing the chat. It's, no legs to be seen so far. We will have issues, but it'll be less. I haven't had that many problems as I did. Yeah, I agree, Stephen. Also, the nice thing about asynchronous is, yes, I'm allowing you to attend the session. I'm allowing you to attend the session, but you are able to watch the recording later. Okay? So let's say you attended the session and there is a lag. You can always go back and catch up if you are missing anything, and you can stop me and ask me to repeat stuff if there is a lag. Because that's just a part of technology. Okay. So week one is posted. Today we'll go into week two. What we're going to do is we're going to continue with the rock cycle. We are also going to talk about soil in more detail and groundwater. I don't think we're going to finish. I don't think we're going to finish, but we'll see how far we get. Okay. That's what we're going to attempt to do. But before we do that, we'll talk a little bit about about week one And we will also go into the assessments and the assessment schedule, okay? All right. So again, any questions or can we continue? Let me switch my camera angle. Any questions or am I good to go? Looks like I'm okay to go. So I'm going to share my screen with you guys. So when I have a class with you, the material for my class will be posted here in the theory portion. Okay. I'm assuming you guys can all see my screen. Can you guys all see my screen? Good. So it'll be posted in the theory, right? And you'll have to talk to Mr. Jovan about the labs portion. My stuff will be posted in in the course content folder in the theory, and I'll give you guys links to whatever you need. That's all you have to focus on. So week one's lecture recording is already posted. And that's on so that's about 43 minutes of lecture there. And you also have some tasks for you as well. Okay, where to get you familiar, to get you into the rhythm. All right. Also, take a look at the supplementary notes. They are meant to help you. They're posted as well. Uh, and you got some information that should be helpful to you about the course. Let's take a look at the assessments now. Just a quick question. Has any of you gone through the week one content? If not, I would suggest you do at some time this week. Okay. Good. Thank you, Simon. How are you doing, Simon?
I'm doing okay. Just been very busy with the summer, mainly just working and spending time with family.
Yeah, that's good.
Yeah,
That's
that's
good.
that's good. Yeah.
Trying to open up your assessment schedule for soil and groundwater. Opening up the wrong folder. Sorry about that. 231. So here are the assessments that you'll have to be providing for me. And as you can see, you have we're not going to have an assessment for a few weeks. There's an assignment for you. It is assignment number one, and it's meant to help you get ready for your test, which will be at the end of October. And then you've got assignment number two, again, worth 5%. It's in early December, it's its due date, and test number two is in December. Okay, I still haven't finalized the format of the test. It's probably going to be an online series of questions that you have to submit, okay? So these are the four assessments, and what I like to do is I like to highlight an assessment when it becomes let's see here. I like to have the I like to have the assessment that's due next or it's imminent in blue. But since it's not imminent, I haven't gotten it highlighted as blue. And once the assessment is done, I like to highlight it as red. Okay. Yes, of course. Of course. Okay. All right, next. What are we doing next? if you don't have any questions about the assignments or assessments at this time, uh, let's get going then. Okay, so we are going to continue with our discussion on soils. What I'm thinking is, so soil is actually material that's broken down of rocks. So if you feel like you need to catch up, go ahead and watch the video from week 1. But soil and groundwater are the main areas that we're going to look at this semester. So when we think about soil, it's basically consists of 4 different parts: minerals, water, air, and organic material. And you can divide it as shown in the pie chart. Now, interestingly, there's a lot less air when you get below the water table. So keep that in mind as we move forward. Now, there are some definitions that should be noted. When you talk about soil, there's 2 types of soils: coarse-grained or fine-grained. Coarser-grained material, that's sand and gravel, are materials that are larger than 0.075 millimeters or 0.074 microns, whereas fine-grained material are smaller than that. That's silt and clay. So let me point out a few things about that before we'll continue. When we talk about soil, in our studies or in our work, when we look at soil, we split it up into 2 types. One is coarse-grained or coarse textured. The other is medium or fine textured. What does this consist of? Sand and gravel. What does the fine grained materials consist of? Silt and clay. And as the slide said, if it's 0.0074 millimeters in diameter or greater, that's coarse. If it's less than, that's medium or fine. This becomes very, very important in our work. Why? Because of how permeable the soil is, how contamination can flow. And in most cases, if you're a environmental technician, you might also have to do work in a company that also does not only environmental work, but geotechnical or construction related. So the soil properties are changed because of the texture. Contamination that flows, contamination transport, contaminant transport would also be another concern, or another reason why we look at soil and its properties in terms of texture. This also impacts how we assign standards to a site. What do I mean by standards? That also impacts how we look at contamination levels. So like, for example, if the soil is generally medium to fine, that means contamination doesn't get transported as easily. So what that also does is it allows for the standards in some cases to be a little more lenient. So higher levels of contaminants can be present at the site in that situation. Whereas for coarser grain material, you have to be a little more cautious. You don't want to have a higher level of concentration in order to avoid having contamination move more easily at the site. Okay, let's continue with the slides. Okay. Now, interestingly, most clay particles are smaller than 0.002 mm. In fact, if you can see the particle, it's probably sand, especially if you can feel it. If you can't, it's clay or silt. So where do you get soils from? Well, the source of soils are rocks. They're from a breakdown of rock material. And the three main rocks that, if you look at it from a geological point of view, three main types of rocks are igneous, sedimentary, and metamorphic. And in the Ross cycle, we have the Earth that's driven by internal energy that melts the rock, that rises a magnet, then it cools and crystallizes. That's your igneous rock. And then you have external factors powering the breakdown, the physical and the chemical weathering into soil, into sediments. And that can then also become sedimentary rocks once they're fused together, especially at the bottom of an ocean. And then sedimentary and igneous rocks that get changed under pressure and temperature are then known as metamorphic rocks. They are metamorphosed. So here are some aspects of igneous rocks. They result from the cooling and hardening of molten rock called magma. And the molten magma, it escapes to the surface and cools or near the surface and crystallizes. So that's why some of the rocks that are actually escape to the outside or above the ground surface, outside, it's an interesting way to put it, are then known as extrusive or volcanic rocks, like basalts, rhyolites, andesites. Whereas the rocks that are heating or cooling down underneath the surface are known as plutonic or intrusive rocks, like gabbros, diorites. And you can see there's different rock texture that also determine what kind of rocks we're looking at. Like when you've got more quartz, then it's granite or rhyolite. And if it's finer grained or fine in texture, it's felsite and obsidian. Whereas the darker colored or the felsic rocks, sorry, the mafic rocks, then you get hornblendite, the gabbro, basalt. So when a rock has the main class of material that a mineral that's quartz, it decomposes usually to sand or gravelly material with less clay. But granites and sanites and relics are in this category. But rocks that also contain a lot of iron, magnesium, and less silicon dioxide, like gabbros, diabases, basalts, are classified as basic rocks. They tend to decompose into silt and clay. So the clay portion of fine textured soil is a result of mainly rock material minerals decomposing to form secondary minerals. So the clays are not present in fragments, it's the decomposition. So clay soils are different in terms of how they behave from gravel, sand, and silt soils. So rocks that are acidic and not basic, such as granites, are considered good construction material. Now, when we look at major characteristics of igneous rocks, many of the combinations are unstable at the surface. And because they're exposed to air, water, chemicals, and so on, they decompose. In essence, the minerals are breaking down. Why is that? Because they're exposed to air, water, chemicals. also the freezing and hotter temperatures, that's what causes the breakdown, weathering and erosion. Now, when you do have this material broken down, it's also known as sediment. And if it piles up on top of each other, cementation takes place, compaction takes place. Silica, calcium carbonate, iron oxides are good cementing minerals in the soil, creating sedimentary rocks like dolomites, shale, sandstone. So so let me just stop here, the sharing. Let me point something out to you guys. Some of the, so let's say you're at Centennial College, right? That's the building. And you want to look at the geological structure. So you might have some fill material that's human placed. That's the result of human activity. That's why it's called fill. And then you'll have native soil. And then at some point you will hit weathered bedrock. And then you'll hit consolidated bedrock. Usually that consolidated bedrock here in Ontario, where we are, it's going to be limestone or shale. So it will be sedimentary. Why? Because where we are now used to be at the bottom of an ocean at one point in history, millions of years ago. And it was where these types of rocks formed. And when you talk about the soil over the bedrock, there's a few terms. It's also called overburden. And because of how it was laid down here in Ontario, it might be called glacial. Glacial till. And an important thing for you to understand. And so let's say this is the ground surface, and this is the soil, the overburden. At some point, it becomes saturated with what? Groundwater. It's the groundwater table. And it's these two areas. So it's the soil, it's the water table. It's these two that we're focused on in this course. Slides. So what happened to form a sedimentary rock was uh, about 200 to 100 million years ago. Where we are in North America was underwater. You don't believe me? Well, let's take a look at somebody who might be able to convince you. Or let's see how I can convince you.
How can you make sure you're drinking healthy water? The only way to know is to test it. In this video, I'm going to show you 3 key tests we offer our clients: contaminant removal, alkaline pH, and antioxidant hydrogen levels.
Really difference. Begins. It seems a lot bigger. Very green. Okay, here's what it looked like. Got the Labrador Seaway, and then you've got the Western Interior Seaway and the Hudson Seaway. So a lot of North America covered with the ocean. And then you've got the glacial period. Now let's take a look at this. So there was an ice dam that was actually built as well. Uh, and a lot of fresh water was released towards Hudson Bay. And they think that this event happened about 10,000 years ago, or 9,000, well, 8,200 years ago, around the end of the Ice Age. As you can see, we still have some velocities that are occurring. What is that? Post glacial rebound. So let me try to explain that to you guys a little bit better. What is a post glacial rebound? As we come to the close to the end of the first part of today's class. So let's say you've got your ground surface here. And a glacier on top of it. So what happens is that the glacier, it actually pushes down on it a little bit. So once the glacier is gone, the ground surface is still a little bit depressed. And over time, it starts to rebound. What that's known as post-glacial rebound. And that's where we are. We still are in the post-glacial rebound. Why? Because we're still just around 10,000 years from the end of the Ice Age. Now, do you guys know why we had an Ice Age? One of the theories that I subscribe to is the planetary alignment. So all the planets aligned from the sun, 1, 2, 3, 4, 5, in such a way that it pulled the Earth a little bit away from the sun for a period of time until it could correct itself, its orbit, in its orbit. That's what caused the Ice Age in my estimation. Okay. All right. So, any questions thus far? Yeah, somebody left the AC on. Is it likely to ever happen again? It is possible. Probably not in our lifetime, so we really shouldn't worry about it. What we should be worried about is climate change. So it's a little bit different where we're losing glaciers. And we think that humans are impacting that by adding gas to the atmosphere. Okay, so we're coming to the end of the first part, and that's the only thing. Until I buy my own version, I will have to split up these classes because they do kick us out after 40 minutes. And the link for the second part is already posted. So when you do leave, don't worry, don't stress out. The link is posted for you guys, okay? We'll probably leave here at the 40-minute mark. And where's the link? Let me give you guys this so that just in case I lose you. Let's go to week 2, part 2. So the link is posted there, okay? All right. So let's get back to here. We've got, like I said, we've got a few minutes left. So you can see there is a rebound still occurring. So shales are usually from clay and silt deposits, and their hardness might depend on what was going on at the time when deposition was occurring and when the cementation was occurring. So this is quite important that how sedimentary rock is going to behave helps the construction industry determine how they're going to lay their foundations, how they're going to perform their construction, especially if it's not that deep in the earth, if it's rather shallow. Okay, all right. So these are some interesting items for you guys to read. Like for example, the carbon chains in oil are tiny by comparison to the micro to the compressed vegetation. All right. This is what the ice slope looked like when it was retreating or coming towards us. And that's why we have these type of structures at different points in southern Ontario. We've got moraines like the Oak Ridges moraine. We've got eskers. We've got deltas and outwash plains as well, which are a lot of Canada and the United States consist of, right? Now, when we do look at rocks that are broken down and they're transported, you're looking at water transportation, gravity also. It plays a part. It could be ice transportation. So ice, like a glacier, can push the material. It can be wind transported as well. And based on them, the type of transport or the method of transport, that's how we refer to the different types of deposits. Is it lacustrine? Well, it's a lake. Is it alluvial or fluvial? It's streams. If it's marine, it's an ocean. Colluvial, it's gravity. So it just rolls down a hill. It's essentially what that means. Deposition by ice, it's a till or a moraine. If it's water, again, it could be lacustrine, alluvial, moraine, and wind could also play a part. And if it's deposited by wind only, it's aeolian. Okay. All right. We will continue after a short break. Like I said, please log on to the other link that's posted there, and we will return in about 5 or so minutes. See you then.